Our topic is absolute max or min and the mean value theorem. Enjoy the lesson. So our topic is absolute max and mins and the mean value theorem. We have three main objectives which we will be covering in our little mini lesson. The first is to determine the absolute max and min of a function, where the value is located and what the value actually is. Second, we are going to use the mean value theorem to find point C between A and B where the tangent line and secant line are parallel. And our third objective is to show that a function satisfies the mean value theorem on a given interval. So we have two main questions. Where will you have a max or min, which is the x value, and what is the max or min value, that is the y. That's very important to remember. Where you will have the max or min value as the x, and what that value actually is the y. So let's discuss places where absolute extreme values exist. 1, we have when the derivative is equal to 0. 2, the derivative is undefined. And 3, the endpoints. Where the derivative is equal to 0 and where the derivative is undefined, which you will see in our example, are the critical points. So the steps to find a max or a min value: find the critical points, which you find by setting the function equal to 0. Find the value of the function at the critical points. Then you want to make an xy chart with the endpoints and the critical points and their values. So our first example is y equals ln of x plus 1 on the interval of 0 to 3. The graph is shown below, and we will explain how to do it next. So we are going to find the absolute max and min of y equals ln x plus 1 on the interval of 0 to 3. The first thing we need to do is find the derivative, which is 1 over x plus 1. We know this is never 0. We do, however, need to find where it's undefined, so we're going to set the denominator equal to 0, and we get x equals negative 1. If we look up on our interval, negative 1 is not part of it. So we need to set up an xy chart. Since we don't have any critical points, we need to include our endpoints, which are 0 and 3. To find the y values, we are going to plug it into the original function. So we have the ln of 0 plus 1, which is the ln of 1, which is 0. Then we have the ln of 3 plus 1, which is the ln of 4. Therefore, our min, our absolute min, is at 0 with a value of 0, and our absolute max is at 3 with a value of ln of 4. So this is the mean value theorem. If f of x is continuous over a to b and differentiable over a to b, then at some point c between a and b, f prime of x equals f of b minus f of a all over b minus a. So we are going to utilize the mean value theorem, which we just learned how to do. Our function is f of x equals 2x squared plus 2x minus 1 on the interval of 0 to 1. So our mean value theorem, if we remember, is f prime of c equals f of b minus f of a all over b minus a. In this case, f prime of c would be the derivative of our function. Instead of having an x, we replace it with a c. So we have 4c plus 2. Then we have f of b. So this is our b, and this is our a. So f of b would be equal to 3. And f of a would be equal to negative 1, so it's minus negative 1, so it's plus 1. And then we have b minus a, which is 1 minus 0, so that's 1. So we have 4c plus 2 equals 4. 4c equals 2, so c equals 1/2. We hope you enjoyed the lesson.